You might not believe it, but every kettle has to have a close encounter with the master before it hits the market. This may sound absurd, but it actually caused quite a stir in 19th century physics. Even if it can last for 10 years without breaking, it still quickly fades from people's sight. Today, let's take a look at the kettle making process that many young people have never seen before. In front of us is the kettle, primarily made of stainless steel. Before production, workers apply a thick layer of lubricant to the surface, then place it on the base, aligning it with the punch. Using hydraulic pressure, they apply a steady force. And in just a moment, the raw material of the kettle takes on a preliminary shape. However, the uneven edges are clearly not usable yet. The steel plate needs to be vertically expanded by extrusion. After checking, move forward, grip firmly, and punch the center. After rough forming, begin fine processing. The worker will first buckle it into the chuck, take out the long stick, and squeeze it hard while adjusting it left and right. During this period, lubricant should be applied continuously to reduce the cracking problem during spinning. Although it is quite laborious to hold this big iron stick, the processing effect is beyond reproach, especially the outer edge, which is almost horizontal. And there is no misalignment. Now let's start making the pot body. Perhaps you didn't expect that the pot body is also made by extrusion. Look carefully. When the steel plate is put into the mold, it will continue to move downward at the same frequency, and then freeze for 2 seconds before it can be lifted up. Carefully pick it up and tear off the film. It looks brand new and undamaged. I have to say that the yield rate is really high, and the extra edges left by the epitaxy must be cut off by the blade on the spinning equipment in front of me. At this point, the pot body is very neat. But the workers still put it on the equipment of the last century and repair the epitaxy again. No wonder everyone says that the old home appliances are strong and durable, such as old fans or pressure cookers, which can be used for more than 20 years. It turns out that it is full of details. As the two parts are formed, welding begins. After the two parts are placed, push them inwards carefully. Then we adjust it up and down, and once both sides are perfectly aligned, we can weld them in place. We set it aside and move on to the next step, making the kettle lid. Compared to the previous steps, making the kettle lid is the most complex part of this round. Just the stamping process alone requires 5 rounds to shape it. For example, after the outer shell is pressed out, we need to immediately change the mold. Press the outer edge evenly, and use an iron hook to pry it out with force, one by one. One looks perfectly fitted, and there is no need to measure the position with a ruler. It is like peshawar being shaped by hand. This is called hard tayozi. After all, the simpler the things, the more durable they are. Here, the middle of the pot lid is also pressed with a significant amplitude. This position is not simple. It is the secret of the sound of boiling water. Right before our eyes, we all know that when water boils, steam is produced, and the pressure changes a little bit. Until the gas is expelled, it creates swirling currents that lead to layers forming and producing sound. This sound resembles a whistle, which is how the whistling kettle got its name. After the workers clean the edges of the iron kettle, they can grip it with one hand and press the outer side to create an oval-shaped groove. This groove is crucial for connecting the spout, making the handling of the spout very careful. Each part is polished inside and out more than 3 times before it can be pushed into the groove, and then it's secured tightly with a piece of furniture. They pick up a hammer and chisel away at the furniture to make the spout fit even more snugly against the kettle body by. Then, it goes into the welding machine, where the rubber on top drops at the same time, to ensure the kettle body remains stable during the welding process. Now we move on to the grinding stage, where 3 workers each focus on a specific area. The first round is rough polishing, mainly smoothing out the larger weld seams, and then gradually moving to finer polishing, which further enhances the appearance's brightness. Next, we start installing the filter screen. At first glance, it doesn't look unique, but it can control the water flow, preventing burns from a strong stream when pouring. Next, the handle is placed at the front and back of the kettle body and welded together. Although this step may not seem very sturdy, but the resistance welding process is quite mature. It should be no problem to use several sides of the kettle body formed by this welding. In addition to this, rivets were used to fix it at first, but I always felt that rivets were stronger, so soon the workers also assembled the lid. As for the scene at the beginning of the video where someone blows into the kettle, it's mainly to check if the kettle can produce sound properly. The method is a bit unusual, but it's the only testing method currently used in this factory. If there were other methods, that would definitely be better. What do you all think about this traditional craftsmanship?